like KOH will give K plus and OH minus ion. And alcohol cha, usually we use ethanol. So ethanol cha bhane C2H5OH, so that will dissociate as C2H5O minus and H plus. So यहाँ तिमीले दुईटा negative species you will get. One is OH minus ion, another one is ethoxide ion. Okay, now this ethoxide ion is better, okay, or it's more basic than OH minus ion. So aqueous ma only OH minus ion is present, water bara pani OH minus pauncha. Alcoholic ma like two species huncha, one is OH and another one timro ethoxide. Now this ethoxide is a strong base, okay, stronger base than this OH minus. So what happen is like timile alkyl, when we talk about alkyl halide, if it have like beta carbon with hydrogen, हैन, so के गर्छ, your base will, now यो base तिम्रो हैन, ethoxide and base ले के गर्छ, proton लाई लगेर जान्छ, it will abstract proton, and the proton लगेपछि now के हुन्छ, यो carbon र this bond hydrogen between the bond between carbon and hydrogen will break, and it will form like the carbon carbon double bond, हैन, with the adjacent carbon, यो alpha carbon, यो beta carbon. So beta elimination we have already done. त्यहाँदेखि के गर्छ, carbon will have like only 4 हैन covalency, so 5 हुँदाखेरि Cl will leave as chloride, and what you are getting here भन्दा at the end you will get alkene as a product, right? So reason के छ, very simple. So aqueous मा aqueous ma OH minus ion cha, so OH minus ion, okay, is like के छ, is a strong nucleophile, so it brought a substitution reaction on alkyl halide and produced alcohol as a major product. त्यहाँदेखि so OH minus ला highly solvated छ, so त्यसले गर्दाखेरि what is solvation means, यसलाई के गर्छ, water molecule ले surround गर्छ हैन, because water molecule is also a polar molecule, यता negative charge छ, so positive like site ले hold this OH minus लाई के गर्छ, यसलाई like solvate गर्छ, and because of that you easily basic character हुनु पाउँदैन, and it will act as a strong nucleophile, and yes, substitution reaction will occur and will get alcohol as a product. अब same कुरा हैन, यता के छ, next मा छ alcoholic medium मा के आउँछ, ethoxide ion आउँछ, र what happened, this ethoxide ion is stronger base than OH minus, यसले beta hydrogen abstract गर्छ, and it will give alkene as a product. Next alcohols are like comparatively more soluble in water हैन, so solubility को कुरा हुन्छ, water मा कुरा हुन्छ, so hydrogen bond, right? So तिम्रो अब alcohol ले like why it is soluble in water, you know the formula of alcohol, ROH हैन, so OH is there, so OH7 is, yes, it form a hydrogen bond हैन, it can form hydrogen bond with water also, so त्यसले गर्दाखेरि चाहिँ water मा छ, it can form hydrogen bond with this water हैन, so त्यसले गर्दाखेरि it is like जति तिम्रो कुनै पनि species या कुनै पनि compound ले, okay, when it like form hydrogen bond with water, then only it is like soluble. अब जस्तै तिमीहरूको के छ, HCl, it is soluble in water, HF, it is soluble in water, HF पनि soluble छ, HCl HCl हैन दो छ तर भए पनि soluble, HF किन soluble हो, and the reason is like it can easily form hydrogen bond with water, भयो. So त्यसरी ammonia, again ammonia, it is soluble in water, why, because it can form hydrogen bond with water, so it is soluble भनेर छ. So alcohol pani soluble, why, because it can form hydrogen bond with water, and it could able to break, like water ma pani already what is there भन्दाखेरि तिम्रो hydrogen bond हुन्छ, water मा पनि hydrogen like bond हुन्छ भयो. So among your water molecule, and यो bond लाई break गरेर it alcohol can form new hydrogen bond with water, so for that reason it is soluble. So hydrocarbon भन्दाखेरि like you will have only carbon and hydrogen, okay, so यसले के form गर्नु सक्दैन, this hydrocarbon is unable to form hydrogen bond, so because of that reason it is insoluble in water. So हामीले जसरी question एउटा गरेको थियो, like this though this is polar हैन, polar छ but it is insoluble in water भनेर गरेको थियो हामीले. अब किन भन्दाखेरि दो इट इज पोलर बट यिनीहरूको यो जुन चाहिँ when it form like new bond with water हैन त्यति बेला के हुन्छ एनर्जी रिलिज हुन्छ so released energy is not sufficient to break this hydrogen bond within the water molecule भयो so again RC halide soluble हुँदैन though it is polar reason किन दो हैन यसको अब लाइक जब यो दिस मोलिक्युल फर्म बन्ड विथ दिस वाटर जुन चाहिँ एनर्जी रिलिज हुन्छ द्याट इज इनसफिसियन्ट टु ब्रेक हाइड्रोजन बन्ड विथ एक्जिस्टिङ विदिन दि वाटर मोलिक्युल सो त्यसले गर्दा इन्सल्युबल छ है सो त्यो सल्युबिलिटी अब के हो तिम्रो हाइड्रोजन बन्डलाई ब्रेक गर्नुको लागि हाइड्रोजन बन्डै फर्म हुनुपर्छ र सल्युबल हुन्छ यहाँ तिमीलाई भनेको छ एल्कोहल क्यान फर्म hydrogen bond already existing between water molecule so it is water soluble hydrocarbon cannot form hydrogen bond and it is insoluble in water now next sa timarko lower alcohol are water soluble so agi discuss gareko cha like lower alcohol means your alcohol with less number of carbon atom just the methanol भयो ethanol so here like number of carbon atom is less so ela lower alcohol bhancha so when the number of carbon atom increases okay then higher ma आइहाल्यो हैन so अब तिम्रो के हुन्छ भन्दाखेरि when the number of carbon atom increase हुन्छ तिम्रो solubility पनि के हुँदै गर्छ घट्दै जान्छ and what is the reason भन्दाखेरि so तिम्रो यो जुन चाहिँ छ यसले हाइड्रोजन बन्ड फर्म गर्छ हैन यहाँ पनि हाइड्रोजन बन्ड फर्म गरे अब यहाँ के हुन्छ बिकज अफ लाइक इंक्रीज इन द नम्बर अफ कार्बन इन अ चेन तिम्रो हाइड्रोफोबिक पार्ट और नन पोलर पार्ट ज्यादा बेसी हुँदै जान्छ okay bigger and bigger so because of increase in number of carbon atom we have already you know very well like carbon chain जुन चाहिँ छ it is hydrophobic one or it is non polar okay so polar part तिम्रो सानो हुन्छ non polar part तिम्रो ठुलो हुन्छ and because of this region solubility के हुँदै गर्छ decrease हुँदै जान्छ okay so lower alcohol can form hydrogen bond with water whereas higher alcohol okay due to presence of your larger hydrocarbon part okay hydrophobic part hydrogen bond is insufficient and inefficient sorry and because of this region your khali ke huncha lower alcohol like methanol ethanol is soluble अब तिमीहरुको propyl छ sprangly soluble हैन butanol हरु insoluble हुँदै जान्छ close the door हम जाऊ त बाहिर close the door now next छ तिमीहरुको what do you like why do phenols not give protonation reaction readily protonation means के हो proton ले attack गर्नु हो now what is proton okay what is proton भन्दा it is your H plus right hydrogen ion so तिम्रो proton मा के हुन्छ like it need electron because positive charge छ हैन oxygen छ भनेपछि lone pair हुन्छ दुईटा lone pair छ and like जति easily this lone pair is available for proton त्यति नै easily के हुन्छ protonation reaction will occur अब when we talk about phenol so we have like done resonating structure so you can easily draw the resonating structure of phenol हैन so where your lone pair is involved in resonance so यो तिमीलाई easily you can draw so your resonating structures हरु तिमीले पुरै बनाउनु सिक्नु पर्यो okay so again this one will come here this one will go here so के हुन्छ then double bond then यहाँ negative charge double bond and O with positive charge again यो यहाँ आउँछ यो यहाँ आउँछ so you'll get यहाँ negative charge here double bond your resonating structure like it's very important भयो again this one will come here this one will go up and you'll get like phenol हैन OH ठिकै छ so what we can see here is like यो जुन चाहिँ lone pair छ it is not only there on oxygen atom okay it is distributing like throughout this ring भयो यो के भयो oxygen atom मा मात्र बसेको छैन यो distribute भएको छ and because of this reason okay so यो के हुन्छ easily this lone pair is not easily available for protonation okay and making protonation difficult जब हामी alcohol को कुरा हुन्छ यो easily protonated हुन्छ why because यो जुन चाहिँ lone pair छ so it will reside only on oxygen atom यो यताउता लाइक डिलोकलाइज्ड हुँदैन. So because of this alcohol easily के हुन्छ protonated हुन्छ and you will get is protonated alcohol. Right? Phenol किन हुँदैन? Because of like your delocalization of lone pair. Okay, due to resonance, through resonance. Now next question छ, phenol boils at higher temperature. Right? So phenol is this one. It boils at higher temperature. So higher temperature को कुरा आयो, solubility को कुरा आयो. So the reason is hydrogen bond only. So you have like phenol, and when the like interaction between the molecule is strong, so it is like it will have high melting point, high boiling point, हैन. अब interaction मा सबसे strong is like तिम्रो hydrogen bond छ. So when we talk about polar molecule, हैन, त्यति बेला के हो, सबसे strong is hydrogen bond. So hydrogen bond छ means like it will have very high melting point. Phenol छ, OH छ, so यसले के गर्छ, easily it can form hydrogen bond with the rest of the molecule. So for this region, so it will have high boiling point. Okay, so this is like intermolecular banja, intermolecular hydrogen bond, because hydrogen bond is formed between two different molecules. Okay, the structures are, so this is your hydrogen bond. So phenolic OH group is involved in intermolecular hydrogen bond, due to which they exist as associated molecule and hence have higher boiling point. So जस्तै such interaction is not there in haloarenes. So what is haloarenes? Benzene ring, okay, and halo means halogen. भाइ यहाँ तिम्रो कुन चाहिँ interaction हुन्छ? हाइड्रोजन बन्ड हुँदैन. हाइड्रोजन बन्ड तिम्रो फर्म हुन्छ हाइड्रोजन, oxygen, nitrogen, hydrogen, and again fluorine, hydrogen. So these are the most electronegative element. Okay, so for that reason it can form hydrogen bond, okay, with hydrogen of some other molecule, yeah, some of other molecule. So haloarenes ma, so the polar चाहिँ हुन्छ हैन, dipole interaction exists, but this like dipole interaction is weaker than hydrogen bond. So त्यसले गर्दाखेरि this phenol have high boiling point, haloarenes have low boiling point of comparable molecular mass. यो छोडिदिउँ. Then next छ तिमीहरूको, out of two chloroethane and ethanol, chloroethanol and ethanol, which one is more acidic? So chloroethanol, this is 2, and ethanol is duita carbon O and H. Okay, now यहाँ के छ भन्दाखेरि so this is electron withdrawing group. Chlorine छ, nitro group छ, these all are electron withdrawing group. So जब electron chlorine ले जान्छ, this carbon will also now like withdraw electron from this carbon atom adjacent, र यो carbon ले के गर्छ, अब oxygen को बाट पनि के गर्छ, electron तान्छ. Okay, we know very well that this oxygen is highly electronegative, so negative र positive छ, and already this bond is like polar, हैन. So polarized, so it releases H plus ion. So हामीलाई याद छ alcohol are acidic in nature. So now out of दुईजनामा चाहिँ को ज्यादा छ भन्दाखेरि, because of electron withdrawing nature यसले electron तान्यो, so अब oxygen ले पनि के गर्छ, hydrogen को बाट electron तान्छ. So because of that यो जुन चाहिँ bond छ, so it like it become more polar. Okay, यसको जुन चाहिँ electron density हुन्छ, किनभने यो लगेर गएको छ because of electron withdrawing nature of this Cl, भयो यो जुन चाहिँ electron density around OH छ, यो के हुन्छ, thin हुन्छ हैन. So thin हुन्छ, so that means it's easily to break it. So easily here like H plus ion will release. So now in this case ethanol ma, this is like electron donating group, हैन, there is no withdrawing group here. So donate गर्छ, alkyl group को plus I effect छ, you know very well. So यसले पनि donate गर्छ, यता polar छ. So त्यसले गर्दा अब oxygen को मा अब जुन चाहिँ pulling tendency छ यो र यो oxygen मा, हैन, from hydrogen यहाँ less हुन्छ, किनभने it is like already इलेक्ट्रोन यसकोमा के छ, बेसी छ, भयो. यता के छ, इलेक्ट्रोन अलरेडी यता बेसी छ, किनभने बिकज अफ प्लस आई इफेक्ट अफ दिस अल्काइल ग्रुप. सो त्यसले गर्दा जुन चाहिँ इलेक्ट्रोन डेन्सिटी छ यहाँ के छ, अलिकति थिक छ, okay, and it is less polar, and because of that H plus ion easily release hundaina. So what is the answer? Out of two, which one is more acidic? 2-chloroethanol. Okay. So minus I effect of chlorine atom, electron density in OH bond, okay, decreases. So OH minus bond of 2-chloroethanol become weaker. Thus the release of H plus ion from OH from this become easier. So the same the plus effect huncha, OH ko density more huncha and it become difficult to release H plus ion. Now next Satimarko, explain why is orthonitrophenol more acidic than orthomethoxyphenol. Same thing. If electron withdrawing group is present, okay, if electron withdrawing group is present, more acidic huncha. If electron donating group is there, okay, less acidic huncha. बुझ्यो बिकज जुन चाहिँ OH bond छ त्यसलाई less polar गर्छ. So what is your phenol छ, okay, and nitro group cha, NO2. So this NO2 is electron withdrawing group. NO2 is electron withdrawing group. भयो. So के गर्छ यसले इलेक्ट्रोन विथड्र गर्छ हैन. त्यहाँदेखि यो कार्बन मोर अब अलिकति इलेक्ट्रोन नेगेटिभ हुन्छ, यसले पनि इलेक्ट्रोन विथड्र गर्छ. यो कार्बन छ यसले पनि इलेक्ट्रोन के गर्छ विथड्र गर्छ. सो यो जुन चाहिँ छ अब यसले अक्सिजन इज मोर इलेक्ट्रोनेगेटिभ, यसकोबाट इलेक्ट्रोन तानेर लग्यो, यो झन् नेगेटिभ भयो. सो त्यसले गर्दाखेरि यसले अब हाइड्रोजनकोबाट पनि मजाले इलेक्ट्रोन तान्छ, and because of that bond become more polar or the electron density around OH become less denser. Okay, कम्ती हुन्छ. इलेक्ट्रोन जहिले पनि याद राख्नु minus I effect increases, minus I effect increases, okay, acidic nature, र plus I effect, okay, decreases acidic character. So now next orthomethoxy one. So this is like OH, methoxy is OCH3. This methoxy group is now electron donating group. यसले के show गर्छ plus I effect, यसले minus I. भयो. So यसले इलेक्ट्रोन दिन्छ, यसले दिन्छ. So oxygen कोमा already electron rich हुन्छ. So यो जुन चाहिँ bond छ यसको pulling tendency from this hydrogen अलिकति कम्ती हुन्छ. Density or electron density बेसी हुन्छ, and because of this, okay, this orthomethoxyphenol is less acidic. So यो दुईटा तिमीले याद गर्नु. तिमीलाई उयो when you arrange them in increasing decreasing order, this is helpful. Rewatch तिम्रो आज स्कुल छ हैन, तिम्रो ढिलो हुँदैन. मैले त्यही भनेर अघि तिमीलाई छिटो छोड्दै थिए के. बुझ्दैछ होला अरु. So nitro group, electron donating group, releasing group. So यसले के गर्छ decreases electron density around OH bond, making it more polar and hence readily releases H plus ion. On the other hand, methoxy group in phenol increases and the electron density on phenolic OH bond, making it less polar and hence release of H plus ion become difficult. So orthonitrophenol is more acidic than orthomethoxyphenol. Now here's the last one maybe. Okay, so orthonitrophenol has a lower boiling point than para-nitrophenol. Explain. So orthonitrophenol, what is the structure? OH NO O. Now यहाँ जुन चाहिँ orthonitrophenol, यहाँ के हुन्छ भन्दाखेरि OH को H and this NO को O, they are very close to each other. So they form hydrogen bond. यो जुन चाहिँ hydrogen bond छ, so this is within the molecule र यसलाई हामीले भन्छ intra hydrogen molecular hydrogen bond. This is your intramolecular hydrogen bond because the hydrogen bond form is within the molecule. Okay, र अर्को छ सो प्यारानाइट्रोफेनल. सो प्यारानाइट्रोफेनलको कुरा आउँदाखेरि NO2 यहाँ हुन्छ, NOH यहाँ हुन्छ. Now, like the two molecule, two groups are far apart from each other, almost opposite 180 degree, like it's a difference in angle ma. Now, because of that, like this O and unitro and OH group is unable to form hydrogen bond. You just यहाँ जुन चाहिँ अर्थोमा फर्म गर्छ यहाँ it's not available. भयो. Now OH free छ यहाँ. Now instead of that, this OH can form hydrogen bond with other molecule of orthonitrophenol. So यसलाई के भन्छ intermolecular. So NO2 hydrogen O, this is NO2, here H. So यो जुन चाहिँ छ intra हो and this one is intermolecular. यो draw structures draw गर्नुपर्छ है. तिमीहरूको के छ like orthoma like के छ since your NO2 and OH group are like very close with each other, so because of that they form intramolecular hydrogen bond. So intramolecular hydrogen bond, when it form, like it will become like isolated molecule. So hydrogen bond यही सक्यो हैन, यो एउटा species मात्रै हो, यो एउटा molecule मात्रै हुन्छ. Now at the interma what is happening is like your molecules are associated through this intermolecular hydrogen bond, and like it will form a large molecule and it become very difficult to break bond. हैन. So अब यसलाई के गर्नु, boiling point melting point को कुरा आउँदाखेरि तिम्रो molecule फ्री बनाउनु हो. So अब अर्थोमा के छ, already like it is like a free molecule as because of intramolecular hydrogen bonding. यो जुन चाहिँ OH छ it is not available for intermolecular hydrogen bonding हैन. So त्यसले गर्दाखेरि यसको boiling point कम्ती हुन्छ. र whereas तिम्रो के छ प्यारानाइट्रोमा, so only intermolecular hydrogen bonding is there, and which is like associated the whole molecule. So you will get is a large molecule associated with it. It will give you a big molecule and it becomes difficult to convert this to a single molecule. So त्यसले गर्दाखेरि प्यारामा के हुन्छ, प्यारानाइट्रोफेनल यसको boiling point high हुन्छ, whereas orthonitrophenol it is still volatile भन्छ, or it will have like low boiling point. भयो. So intra ले जहिले पनि boiling point ले decrease गर्छ र inter ले जहिले पनि increase गर्छ, त्यो याद राख्नु. So due to presence of intra-hydrogen bonding in orthonitrophenol, it has lower boiling point, while para-nitrophenol is less volatile due to intermolecular hydrogen bonding, which causes the association of molecules. Right? So inter छ भने चाहिँ boiling point हरु high हुन्छ, melting point high हुन्छ, soluble हुन्छ. Intra मा हुँदैन है. Okay, so तिमीहरुको छ this molecule reaction with HI gives this thing. यो हामीले गरेको छ, पहिला हिजोस्ति गरेको छ. Okay, so when you react is with HI, so we have done like when different degree, अब बिर्सेको छ होला, please अब यो revise गर्दै गर्छ. When like on the either side of this oxygen, if we have different degree of carbon atom, 1 degree ho, this one is 3 degree because no hydrogen there is with this carbon atom. 1 degree, 3 degree, जहिले पनि cleavage कहाँ हुन्छ भन्दाखेरि तिम्रो higher degree मा हुन्छ, and what you will get here is CH3, okay, 3C यता जहाँ चाहिँ छ यहाँ I आउँछ, अर्कोमा H आउँछ, so you will get is this one. It gives यो भन्दैछ, ठिकै छ, and not CH उल्टा हुँदैन, यसको उल्टा हुँदैन, यो त हामीले यादै छ. We'll get this, ठिकै छ, will not get CH3I or यता OH पाउँदैन. And question सोध्दैछ किन higher degree मै break हुन्छ भन्दाखेरि the reaction proceed like कसरी proceed हुन्छ, यहाँ H यहाँ के छ, what is there, so HI will dissociate as H plus and I minus. भयो. त्यहाँदेखि we have ether O CH3 lone pair छ, okay, and we have like H plus proton छ, lone pair वाला oxygen छ protonation भइहाल्छ जहिले पनि. If you have alcohol, if you have proton, okay, so protonation will occur. If we have ether which have lone pair, so proton ले attack गरिहाल्छ, so we'll get is like CH3 whole 3 C, okay, then O positive and CH3 भाइ यता H पनि आउँछ. So H protonation भयो. अब यहाँ के हुन्छ भन्दा like we know very well like this oxygen is highly electronegative, so oxygen को मा positive charge बसी बस्दैन. So अब यसले यो positive charge लाई neutralize गर्नुको लागि, my goodness, baby, okay, so के हुन्छ भन्दाखेरि अब यो तिम्रो bond polar अब like oxygen is highly negative, यसको positive charge बग्दैन, so that means यसले के गर्छ electron pair तानेर लानु पर्यो. यहाँबाट तान्छ, यहाँबाट तान्छ, okay, either side बाट. Suppose A र B, so A, if it follows path A follow गर्दा what you will get here is like CH3 whole 3 C positive पाउँछौ तिमीले, भयो. If it follows path B, then what you will get is like CH3. If the bond between O and the CH3 break, you will get is CH3 plus ion. Right? Now here you see duita pathway ma like you are getting is two different carbocation. Okay. Now out of two, jun चाहिँ stable हुन्छ. Okay, त्यो form हुन्छ. Now see, this is a 3 degree carbocation. This is 1 degree carbocation. Okay, 3 degree and 1 degree. And we know very well that higher degree of carbocation is more stable than the lower degree of carbocation. Okay, so that means, so instead of forming CH3 as a carbocation, what we are going to get here is CH3H plus. Yo form huncha, not this one. Okay. Now, jaba हामीले this carbocation आउँछ, so your molecule at the same time what we are getting here is CH3OH if it follows path A. Okay, and eta cha, so you have like free I minus ion in solution that will attack this carbocation, and finally we'll get is tertiary halide. Okay, the reason is very simple. Okay, so eta okay, reason मैले लेखेको रहेन रहेछु again this one. Okay, so you need to write down the mechanism. So the mechanism follows the following step. Number one is like protonation will occur, है ना, HI cha, so it will give proton and I minus ion. First step is protonation of your ether, will get is CH3 whole 3 C, then O CH3, so protonation will occur, so that means we'll get is CH3 C, okay, then O H, yeah, positive charge huncha, then CH3. So as soon as you will get protonated ether, and a positive charge of oxygen has to be like neutralized. हुँदै हुँदैन positive, किनभने it is more electronegative than the species which is around, हैन, carbon hydrogen भन्दा more electronegative हो. So अब यो negative positive charge ले neutralize गर्नुको लागि अब कहाँबाट neutralize गर्छ भन्दाखेरि यो this carbon and this oxygen. Why this carbon? Because when the bond between the two break, we'll get is tertiary carbocation, and this one is very stable compared to the primary. And orco molecule के हुन्छ तिम्रो CH3 is there, then OH, हैन, and finally this is step 2, and finally, so like you have carbocation, you slow step हो, so you like this is slow step. Fast step is like as soon as you will get carbocation, I minus is there, okay, the two will combine and will get is CH3 whole 3 Ci as a product. So this is like the stable carbocation.